My name is Hunter Fowkes, and I am excited to bring you along on a potential chase here in the next couple of days. To start off, we're looking at a potentially big event here on Monday. And as we can see here, I have the Storm Prediction Center's Outlook page up. For the day 4 time period, which is Monday, this coming Monday, is a 15 and 30% risk for significant severe weather. And a 30% risk is the highest potential risk that they issue on the 4 and beyond day period. So this is potentially looking to be a widespread event. As we can see, the 30% risk area is over a huge expanse of region where there may be significant severe weather. So we're going to spend some time looking at the day 4 forecast for now and see where Model Land is placing this thing at and potentially where we could see some tornadoes. Look forward to bringing you along with me. So to begin with, first here, I am a Euro lover, the European model. So most of this forecast, the day 4 time period, is going to be based off of this model. We will compare with a few others as we go through some things, but for the most part, we're going to be looking at this. And my personal forecast process is a top-down forecast where I begin aloft at about 300 millibars at the top of the atmosphere or the troposphere, and we work our way down. And the reason for that is I personally believe, and this is just a personal opinion, if you can sort out the problems with the aloft, which generally helps with forcing or areas of center suppression, that generally helps out with choosing a target area and generally where you need to be. So we're going to start with that first, work our way down to the surface, and figure out where we're going to end up storm chasing. With Monday, that is 4 days out, so what do we have going on? We've got persistent west coast troughing for the most part and a large ridge axis that pretty much dominates the eastern two-thirds of the country. We see that the troughing leads to a pretty potent upper-level low diving into the Four Corners region before eventually ejecting come Monday and rapidly doing so. Now, something I have noticed is that this trough, not so much maintaining its bowling ball feature. It's really elongating out, phasing with some other portions of energy aloft, and that's causing this system to really fall apart.
The Chaser Academy is our premium subscription, and it's the best deal in storm chasing. Link in the description.
To begin with, the trough reaches maturity as it enters the United States, with the jet streak rounding the base and leading ahead of the trough. That'll mean the bowling ball of an upper level low will lift off to the north rather than continue to dig southward. So we expect this kind of trough to fall apart aloft and lead to a fairly potent jet streak moving across the area. And when I say potent, we're looking at potentially upwards to 90 to 100 knots in the core of the jet streak itself. But for the most part, we're looking at 80 to 90 knots of flow aloft to 300 millibars. Now, because there is some curvature aloft, but it's generally a straight jet, we still can use and look for left exit, right entrance region. When it becomes more straight of a jet, you generally want to just put yourself right in the middle of it. I like to just look for, when I have a straight jet, try to find where the peak of that forcing is going to go. But if it gets a little more curved, I generally start to favor more left exit region or right entrance region. And in this case, looking at this upcoming Monday, we see by 21Z on Monday or 4 p.m., we see that a general left exit region may exist generally up here. And actually, let's draw this so I can visualize this a little bit better. Seems like the jet streak is relegated in here. That's like the strongest portion of the jet streak. And doing our basic quadrants here, we see the left exit by 21Z is still well out to the west. And actually, looking at this, I think I'm misdrawing this a little bit. Let's actually draw this a little bit better. And it seems like big elongated jet streak here. The center axis of it here and the center axis of it here. See, the left exit region is really getting involved into the Minnesota and northern Iowa portion. Right exits is taking up much of the area to the south over like Kansas City and area. And the right entrance region is lagging out behind with the left entrance region way back out here. The areas we're looking for that generally going to favor a little bit better spin motion in the atmosphere aloft and provide lift rather than suppression are going to be our left exit region and our right entrance region, with a cold front that is going to be draped, and I apologize for all the lines, like this by this point. It seems like for the most part, we're probably going to be dealing with some synoptic suppression across Kansas, northwest Missouri, and parts of central southern Iowa by 4 p.m. And Minnesota into northwest Iowa, maybe even central Iowa, depending on how you draw this, could actually still see some synoptic lift as well with this upcoming trough. So it seems like there's going to be some decent lift with this upcoming system, and with it basically pointed as a straight jet across the entirety of the northern portion of this risk area, that's probably going to mean a lot of storms, probably a whole line of either QLCS style or Supercell type storms all across this Pacific cold front, and we'll dive into that. If we take a look at how things are behaving across the model suite, because it's always a good thing to do, and at the day 4 range, there's still plenty of time for things to change, and this is how the euro has trended over time. We see that maybe some weaker flow out aloft, and a little bit more elongating of the trough itself once it gets into the area. But looking over all the models, seems like we've got pretty remarkable agreement that this is where the placement of at least this trough will be. There's some discrepancy in between where the upper level low kind of falls apart at and how much it holds on together. Some models have it a little stronger holding on. The Euro model has it falling apart and elongating a little bit, but they're all fairly similar for the most part where that jet streak is going. For 500 millibars, this is something that actually has had some recent research with something called the Omega Project, which was a research paper done by Chris Broyles at the Storm Prediction Center, that he found that if jet streaks translate very fast during an event, they tend to help separate higher end tornado events. Now, this event to me potentially looks like it'll be a significant tornado event, and we'll go over that. But it seems if this jet streak translates quickly, this might lead to a potentially higher end scenario if everything else falls in line. And if we look at just even the Euro model here, right, we want to look at how fast this 500 millibar jet streak travels. And here is 0Z on Monday, which is 7 p.m. Sunday, Central Time, excuse me. We see that the jet streak here is across the southern Four Corners region, but by the same time on Monday at 7 p.m., it's all the way in the Great Lakes. So this jet streak is flying across into our warm sector, slamming right in, which will likely lead to some pretty robust cooling aloft and rapid instability development and thunderstorm development. So from a chaser perspective, sudden robust thunderstorm development is exactly what we want to see in the right areas at the right time. So it seems like this jet streak is translating fast enough to get into the picture by 1 p.m., 4 p.m. and somewhere in between that time period. So we're looking at plenty of synoptic level forcing. I feel pretty confident with this potential upcoming event that I'm probably going to start looking more towards southern Minnesota, maybe central Minnesota at most, down into western and northwest central Iowa, that kind of region, if I can draw here. I'm looking at this kind of zone here for potential severe weather that would favor supercells and tornadoes that are photogenic enough for me to enjoy chasing. That is the goal. We want to see pretty tornadoes, potentially even the strong ones. We want to obviously go see the best of what we can do and hope that these tornadoes stay out over open cornfield and do no damage. But it seems like this is going to be the heightened area that we're going to want to pay attention to. Again, if we follow the same method and look across the board at what are the other models thinking, is this a similar situation? And looks like we are very much in agreement that this jet streak pretty much is directly over Iowa, punching into Minnesota, depending on the model. Sometimes it gets into Wisconsin, but generally we've got pretty solid agreement of where this trough and its subsequent forcing is going to be. Now, it is going to be a very positively tilted trough, which may lead to a lot of suppression down the cold front, which is why I'm leaning more towards the front end up in Minnesota and Iowa. I was originally potentially looking at chasing down in Kansas, but noticing how this very positively tilted trough is behaving, I don't really want to chase an area that is being synoptically suppressed, because even if you remove your cap and your jet streak misses off to the north, that might not give you enough lift to really get a thunderstorm going. Now, you can overcome that with surface boundaries and whatnot, and we'll look at that here in a moment, but synoptically, it's looking less favorable. Doesn't mean there won't be storms, but for me, I'm looking more in that northern mode for potentially better severe weather to chase. Moving our way down, right? We want to continue our way down. We want to look for now at 700 millibars. We want to see what type of flow is happening at that level, because this is where orientation to our boundaries are going to become very important. Since we've now already highlighted that we're looking at the northern mode, so we're going to just focus on that as a chase target. Here we get into Monday here by 10 a.m. Now we get to 1 p.m. and we see just incredible transport here at 700 millibars, which if we pull some soundings and we will it a little bit, we are likely going to see some EML transport, especially since this gets here in less than 24 hours from the Rocky Mountains to the upper Midwest. That is a very fast translate speed. I do not expect this to be muddled whatsoever, and getting 40, 50 plus knots of flow here at 1 p.m. is very strong indication of very good EML transport across our warm sector here across the board. So I am seeing plenty of green lights here. And I figured we actually look at temperature here aloft, which is an important factor. Generally, I want to see caps at 700 millibar temperatures to be cooler. I should say warmer than 8 degrees Celsius and cooler than 12. That puts it at a pretty good cap. And since we already have seen lots of forcing come slamming in, we can lean a little higher to keep things from blowing up over our warm sector before our storm system gets in. And by 1 p.m., yeah, we're seeing 9 to 10 degrees Celsius temperatures here across the open warm sector. And as we go further west, we see cooling rapidly dropping off. Forcing is arriving, cooling our 700 millibar area, removing our instant inhibition with the cap, and likely we're going to go boom probably after 1 p.m. I wouldn't be surprised by 2 p.m. if we start seeing storms pop up along that cold front that'll be sweeping through the area across the upper Midwest. So I'm already seeing this is a great sign for a potential outbreak of severe weather because of the overall expanse, just the expanse alone of the region that could potentially be involved. We like to look at height falls here. This is going back to 500 millibars, but we see here plenty of height falls going into Monday here. We're seeing heights fall across the board, which is an encouraging lift. Again, we're getting the same idea that we've already talked about, but we're checking boxes here as we're going down the atmosphere at the day 4 range. This is looking potentially really fun for a storm chaser. 850 millibars, we're basically just looking here to see what type of low-level jet and mass response transport is happening here. Was moisture funneling northward? Do we have strong enough flow to maintain low-level curved photographs? That's the idea of what we're looking for. As we see by Monday, by 1 a.m. Central Time, we see the low-level jet really ramp up with the approach of that system. We see as we go through the day an obvious weakening. As we know, the low-level jet weakens during the diurnal cycle of the sun. So when the sun is up in the sky, the low-level jet weakens because friction plays a bigger role in the atmosphere, friction with the surface. And so that causes the low-level jet to weaken. And then at night, things start to cool. We get an inversion and the low-level jet ramps back up again. But the fact that we're maintaining at 1 p.m. a 30 to 40 knot low-level jet is not nothing. That is a sufficient low-level jet to maintain some type of low-level turning in the photographs and increasing that low-level shear. And as we get to 4 p.m., we're now bumping up towards 50. This is till the evening. This is now 7 p.m. and we're now seeing a 60 knot low-level jet. So we're really ramping the low-level shear quickly over the hours from initiation time generally being around potentially 2 o'clock, 3 o'clock to now 7 p.m. We should be heavily rocking and rolling with significant severe weather. It may not be necessarily tornadoes, but this will be an environment very favorable for severe weather based off this low-level jet transport alone. We want to look at moisture at this level at 850 millibars because a big thing for me as a storm chaser is I want to see dew points that are going to be reaching 12 degrees Celsius or higher at this level because this is indicative of how deep that moisture layer is. In Iowa and the upper Midwest, you're only a few hundred feet above sea level, not even 1,000 feet above sea level. So you have a large column of air to really work with in these lower levels of the planet. So compared to areas where I am, where I currently live above 500 or 850 millibars due to my elevation. But down here, you've got a lot more to work with, and moisture transport is a very important thing. And as we see here, already, look at this, already at midnight, 1 a.m., we already have the moisture. I'm already quoting for a minimum of 12 degrees Celsius. And we see that moisture continue to maintain. Arguably, this is some very deep, rich moisture coming across here in this low-level jet transport, 14 to 50 degrees Celsius. That'll mean our boundary layer has tons of moisture all the way through to the peak before it hits the ML. So looking like a potentially robust environment just from this alone. Now we want to take a look at the surface, and immediately we're going to go right to dew point. To me, this is one of the most important things we need to look at. Surface is dew point with wind barbs because we want to see where that wind is blowing and the moisture content with it because that'll bring the instability. As we get towards Sunday, we see already that moisture plume is already expanding into the region. By 7 a.m., we already have a deep moisture plume potentially pushing into the mid-60s, low mid-60s by the morning. And as that translates east and the air warms and we get more moisture funneled northward, look at this. The two things immediately stand out is the expanse, the breadth of how wide this warm sector is, which is a major calling card of a substantial severe weather event because storms are allowed to continue across a wide region in an unstable air mass. Even getting up to Minnesota, we're talking the length of Minnesota and even further instability of dew points at least 60 or greater up near the surface low and trailing all the way down. This is a very deep, rich moisture environment. We see that axis of instability really builds in here. This is something also I really like to keep track of. So you have the breadth of the entire warm sector, right? You can draw it in like this. The biggest thing that I like to keep track of, where's the axis of that instability or the middle point of the instability axis? And it seems like this is pretty much more or less, give or take, the middle point of that axis. And I like to see storms either right on the tip of the axis or behind the axis moving into that. And why do I want that? And it's because this peak middle zone is going to be the key area of the best instability, the best moisture, and potentially even some wind shear as well as you get temperature differences across the warm sector as well. Sometimes winds tend to be a little bit more backed on the right side of the axis, and then on the west side, you tend to have a little bit more veered. So as you get closer into that axis, you're just building more instability, you're building into better wind shear. It's just a great combination of this. And so it seems like this area that across central Minnesota, and actually let me erase this so this doesn't get too chaotic, it looks like we're pretty much going to be dealing with a really solid air mass here out and ahead of the Pacific cold front, which you can see denoted like this, out ahead of the cold front. So we have lots of instability to work with. We're right ahead of the axis, plenty of pumping and moisture. So this seems to be our key areas that we're looking for. And if we think about what we talked about earlier is looking for those areas that are synoptically favored as well. And if you remember, we already found that we are going to be dealing with synoptic lift in this northern mode, and then potentially some more suppression on the southern mode due to the left exit and right exit regions. So this automatically tells me as a storm chaser, because I love chasing in the left exit region, I think it's the best place to chase. You can ask individual storm chasers, they have other opinions, but this zone tends to be more favored, and I think our best chance is going to be maximizing between the two combinations of synoptic lift and the best area to chase for moisture and the instability access. One more thing I do want to discuss here before we move on is why also at the surface am I thinking about chasing in this region? Because we talked a little bit previously about line orientation or initiating boundary orientation. And I'm going to go up here to 21Z here on Monday. And what we see here is we have a nice low pressure center out here. So our low pressure sits out here. Got a nice warm front draped out more or less like this. And we get a cold front that looks to be draped more or less like this, and a more or less Pacific front dry line feature. We'll denote it as a dry line, but it's a cold front dry line feature called a Pacific front. It comes slamming through this point here. And so we see here that there is a zone where you have the interface of different front boundaries. You've got a great zone underneath the low here, and then a secondary zone here down along a potential triple point. And these are going to be favorable zones for us to potentially storm chase. So from a surface boundary, that's great. But there is one caveat when I was briefly looking through the models here of something that I'm not the biggest fan of, and it is the orientation to that boundary. So if we actually keep the fronts up here, we see by 21Z, we want to look for areas that are going to have perpendicular flow. If I bring over my little notepad here, we'll do a quick little drawing. So what we see here, what we want most when we're out chasing is we want a front that is very much north to south, and flow is either coming perpendicularly or just slightly off perpendicular to that front, because that'll cause storms that form to immediately form on it and get out of there. That'll encourage more discrete storm modes rather than things getting messy. Things get messy when boundaries and the lines are very much aligned or parallel. That'll lead to lots of updrafts forming, which, yay, we get storms, but then they never leave that zone of lift. And so you get storms that kind of form on the flanks of other storms, and they get really junky and gross. And congratulations, you've now just formed a QLCS. You can have the same exact conditions that supercells love to thrive in, but now you have too many of them, and they all form a big old line. And that is a gross storm mode. We do not want to chase this. We're looking more for this discrete mode. So where are we going to try? Where are we going to be able to find this? This should not come to many as a shock that the northern mode seems to be doing that better, right? If we go back here to 21Z, and actually since it keeps sliding back and forth, let's just get the thing set. And we see here, based off of these front locations, the best possible zone for kind of discrete convection may be way down south here in Kansas, and then again here along this triple point boundary up into the low as well. And if I clean this all up again, and let's go in a much tighter sector here across the Midwest here, and go back to the dew points, we see that the low is up here, right? And the cold front kind of extends down this way, more or less. Seems like we already have thunderstorms ongoing here, and that's why the dew points are all pop marked like this, so the model's already depicting storms are going. But we saw that wind flow was more like this at 700 millibars. And then down here, a little bit more parallel. So this is what I'm thinking, leaning more towards the zone that I'm particularly more interested in chasing may actually end up being this more northern mode because we have already determined we have lift right at the tip of the axis, the theta E gradient pulling right into where we want it to be. We're getting a little bit more of a north-south type of boundary orientation. We're getting, I'd say, or mostly perpendicular flow, semi-perpendicular flow across our boundary. So this is all kind of funneling into this decision process of where should I storm chase. I would not be surprised if I pull up the Cape map, and we'll probably just do that now, and see where's the biggest Cape, and is that where I should go? And I don't know if that's always the right answer. Is Cape the place to be? And we see that there is a bullseyes of Cape here across southern Kansas into central Kansas, and again, Missouri and Iowa, but we've already denoted that there is suppression there. So likely the cap might end up being a little stronger. That leads to a little bit better instability. The area that I'm likely targeting is actually going to be up where there's a little bit less instability, but it is funneling into, right? That instability is moving. When you think about weather maps and everything, you got to realize that it is a fluid and it is moving. And in this case, I'm leaning towards potentially chasing up in this northern Iowa, southern Minnesota region come Monday based on all these factors. I want to pull some soundings here while we have this up. We'll do this at 18Z. Take a look here. We see up here in Minnesota is west central Minnesota, plenty of instability, almost a 2 kilometer deep moisture layer. We've got some 3 Cape already building at 1 p.m. The sun is out. Modest shear, but again, we know the forcing hasn't quite gotten there yet. Looks like it's almost there. So it looks like maybe a little more time, but this is already looking like a robust environment. We've got an EML aloft, plenty of steep lapse rates, which are looking 7 to 8.0 or greater. And a good quote for storm chasers is if the lapse rates are 8 or better, the storms are going to be great. 8 is great, basically. That means storms are going to look a lot more chunky and fun and potentially be a little bit more robust with steeper lapse rates. Whether they are low level or mid levels, they tend to give you lots of instability. Looking here across west central Iowa, and we see more of the same, just a stout elevated mix layer, lots of steep lapse rates aloft, big Cape. Great temperature spread, 77 or 64 is amazing. Low LCLs. The photograph is fairly straight at this point, but again, we showed the low-level jet decreasing. We now expect it to ramp to 50 knots to the northeast. So you can honestly take that up here and now imagine what that low-level photograph would look like, and it's probably going to get pretty monstrous with a 50 to 60 knot low-level jet by 7 p.m. So things are looking pretty robust, and let's take a look down here in Kansas. And we're seeing a little bit more of a cap inversion, so we're still needing a little bit more to get things going. And actually taking a look here, the current surface temperature according to the Euro model has 81, but convective temperature is 89 degrees Fahrenheit, which means you either need to warm this profile to that temperature at the surface to generate thunderstorms, which would be a really widespread and big inverted V lower sounding here with really bad or mid 60 dew points and temps almost at 90 degrees. That's pretty rough spread. Very elevated storms with that kind of environment. But it seems like the forcing hasn't quite reached this zone and we maintain capping. So this is leading towards my decision of moving away from chasing in Kansas to likely more moving towards Iowa, where potentially some better forcing and lift is there and remove of the cap itself. Let's take a quick look at 21Z and we'll pull a sounding here near the Twin Cities. Hopefully it's not too contaminated. I forgot the Euro doesn't do contamination bars. That's fine. But we see, the low-level jet has increased to 40, 45 knots. So we see much better low-level turning, plenty of length of photograph, almost 60 knots effective bulk shear. Perfect. Over 50, 3 Cape, perfect. LCL below 1 kilometer, perfect. Like, I hope as you're watching along and wanting to learn, and as I'm rapid firing through all of this, it seems like this is becoming pretty good for rotating storms, supercells, and some tornadoes. Let's pull another sounding here in northeastern Iowa, north central Iowa. We see more of the same. The cap is entirely removed. We have an EML. We have great temperature dew point spread, some low-level turning, decent length photograph, over 50 knots of bulk shear, plenty sufficient, 1 kilometer bases. We're checking boxes here, folks. These are things that are, as an experienced storm chaser, you just check when you're looking for environments that are favorable for producing tornadoes. And then finally, let's take one. We'll take one here and then one more in Kansas, northern Missouri. We're starting to see, as we're moving away from the forcing, we're still seeing more of a straight photograph and a little bit weaker bulk shear. Now, 45 knots of bulk shear is still plenty sufficient, but you're noticing things decreasing as we're moving south, as we're moving out of that better lift, better forcing aloft. Seems to be a common theme that is developing, and the low-level jet is not nearly as strong, especially early in the afternoon to start it off. So immediately, we're not too excited about this, and we'll pull another sounding here in Kansas. Surprisingly, we do actually see that the entire area has completely destabilized. The SIN has been removed, so that's a great sign, but Notice the complete lack of low-level turning. And I would say for anyone that is knows me is I wish we could get rid of these possible hazard type boxes because they're useless. Because this type of sounding is much more favorable for large hail development. Not so much tornadoes. Does not mean you couldn't get one, but the robust tornado threat seems to be much weaker in the afternoon across this area here. And then finally, let's take a look at where things go by 7 p.m. And it looks like storms have rapidly plowed through into Wisconsin across the northern zone by 7 p.m. So it seems like portions of Wisconsin are back under the threat, eastern Iowa, and as we can see here, the cold front has not moved and the instability is still building. So that means no thunderstorms are being developed here by this European model run. So let's take some soundings. And I can already tell you this is probably going to be a monstrous photograph, and it is. We see that some convective inhibition is starting to build back in as you're getting too far east out of the moisture axis. It's not too surprising, but we still maintain very strong low-level curvature, almost 300 0-1 SRH and 30 storm relative inflow, indicating big storms. They'll likely rotate very strongly. Even if you start building in some inhibition, these storms likely plow through, although I expect more of a QLCS line to the north by this point. Then we continue south into, let's go west of the Quad Cities, maybe towards Cedar Rapids. And we see, again, more of the same situation, a little bit of sin trying to build in by 7 p.m., but we still maintain a very strong low-level jet as we continue through. So I think this robust tornado threat may even continue into the evening, even though some models are trying to indicate some convective inhibition coming in. But again, this is a global model, not a convective allowing model. So the more specifics we'll get in the next couple of days with the HER model with time. But for now, this is looking like we're guns blazing of an event. Looking here into northwest Missouri, where they're clearly in synoptic expression, and look at the photograph shape change, where it really has not increased all that much and still maintains a very straight type of profile. Still expect robust severe thunderstorm development and still a tornado threat, but potentially the significant tornado threat might start diminishing as we move southward unless these photographs can change with time. I'm sure Kansas City is happy to hear this news because they don't need significant tornadoes in their area, now do they? And then here in Kansas, near the Emporia, Kansas area, and we see more of the same that we saw in Missouri, just a modest low-level curvature of the photograph and straight, so favoring hail, plenty of instability, great profile for robust severe thunderstorms, still a tornado threat, but it looks like the threat here is a little bit lower on the strong side, but I would still expect robust thunderstorms and a tornado threat at this point. But now as we get to 7 p.m., we're starting to get towards dark. And if there's no storms down here, you're looking at a potential evening into overnight situation. So it seems like the best chance for tornadoes, at least according to this Euro model run, seems to be more up to the north with a delayed late evening overnight tornado threat if the cap is able to be overcome and suppression is able to be overcome further down south along the cold front itself. So that seems to be what we're working with here. I wanted to pull up quickly just to look at the dew point line and compare to other models just to see, is this Euro model really on something or is it out to lunch? And if we look at the Euro to the GFS, almost identical. And the GFS even has a more vertical north-south line, which would be very dangerous for even more robust thunderstorm development and more supercell chances as you have better line orientation shear. So we continue on. Looks like moving through the models, we just continue the same idea. NAM doesn't seem to be as farther north compared to the global models, GFS and Euro. Tends to have it a little bit further south. Warm front's about in the same location as is, but notice the due southerlies compared to, let's say, the Euro, where the Euro's a little bit more progressive, probably with a potential QLCS squall line. The NAM keeps things maybe a little bit further west with more southerlies, and that will probably lead to more robust low-level turning in the photographs. Still veered flow out of the southwest down here, so I would still expect the same conditions to continue, but notice the wind profile change and boundary location change between the models. So there's still some discrepancy on how the later half of the event plays out. And looking at other models here, like the RFS, a famous model for storm chasers, let's actually step back here so we can get a better idea of what this looks like. The RFS is continuing deep 60 plus dew points, north-south dry line, essentially cold front dry line combination. Very potent look here from this CAM model and this NSSL MPAS model, another really good CAM model to play around with. Also showing potentially a dry line bulge here into parts of western Iowa, north of the Omaha area. So the northwest Iowa area would be heavily, for me, like I would be heavily interested in this location as a storm chaser right on the tip of that zone. So we'll have to see if those features play. GFS has one a little bit further to the north. Euro really doesn't have one, so to speak. NAM might have one here. RFS and the CAM models are having a little further south as well. So this might turn into something potentially really interesting for us to storm chase. And I wanted to bring this back out because as we're dealing with a widespread event, this is kind of like my checkbox for looking for a significant severe weather event. We have located favorable synoptic zones of lift, and they seem to be actually in play in the warm sector of this setup. So we check that box there. Deep, robust moisture and how expansive the moisture is. We've checked those boxes. It's going to be expansive and very deep moisture. This is not going to be shallow moisture at all. Storms are going to thrive in this environment. Strong instability and sufficient lapse rates. We've talked about that. All the soundings from whether from Minnesota all the way down into Kansas, we're talking 8.0 degrees Celsius per kilometer lapse rates at most levels. We're talking about 2,000 to 3,000 joules per kilogram of surface-based and mixed layer CAPE. Fantastic instability across the board. Dry and cold air aloft kind of ties into those mid-level lapse rates, and we seem to be having those. We're having cold temperatures aloft at 500 millibars move into the region. And we see by 21Z, we still maintain pretty warm temperatures actually across here with some cooler temperatures back west, but nothing too crazy at this level. Some cold air, nothing remarkable. Here at 700 millibars, you'll see that the capping really does just erode out here to the west where we're dropping 4 degrees Celsius at 700 millibars, and that'll just explode your caps. I would anticipate probably very robust thunderstorm development almost instantaneously when it's time to go, probably by 2 p.m. on Monday. So it seems to be the forecast is where we're looking is we're targeting this northwest Iowa, southern Minnesota region. Looks to be synoptically favored, robust deep moisture, great shear that it improves with time, and mostly favorable boundary orientation, although my biggest worry is this turns more into a QLCS threat rather than discrete supercells. But depending on what model you look at, maybe that won't be too much of an issue. Maybe it is. That's something we're going to want to work out over the next couple of days. So I look forward to doing another one of these updates as we get closer, when we can actually look through some of the cams, and we'll see how this forecast plays out in the coming days. Right now, again, this is 4 days out from the event. I look forward to viewing the models going forward, and I look forward to giving an update either Sunday night or Monday morning of where I'm thinking of targeting, and I look forward to bringing you all along with me. So this will be exciting, and I hope you enjoy. Hello everyone, just a quick little insert from Future Hunter. Now it's April 30th as I'm making this video, but between day 4 and the chase day, there wasn't too many update videos because there wasn't too much change in the forecast. So now we're going to jump from a pretty thorough day 4 forecast after deciding to commit to the storm chase across the upper Midwest. We're going to jump now to the morning forecast about 8 a.m. in Lincoln, Nebraska on April 28th. To see what we're going to do. Where is our chase area going to be? How is the forecast looking based off of where we've looked at, where are things currently now, and where we're going to go for our storm chase that day. So let's toss it now back to Pass Hunter on April 28th.
Hello everyone, it is currently Monday, April 28th, and we are currently looking at a potential significant day of severe weather here. Apologize for using the phone here for the screen here, but we should be able to get a good little forecast discussion here this morning. Currently 8:41 a.m. and we are currently situated here in Lincoln, Nebraska, and it looks like we have a pretty potent day on tap. It looks like we have a level 4 out of 5 severe weather day. The SBC in Norman has issued a moderate risk for severe thunderstorms here across portions of Minnesota, Wisconsin, and northern Iowa, with a larger enhanced risk over the same general region extending down into the plains, and as well as an enhanced risk down here across western Oklahoma into parts of Texas that was just recently added with the 7 a.m. outlook. So pretty much it looks like we've got a pretty significant day for tornadoes here. Our forecast over the last few days has pretty much been unchanged from our previous video, where we've been honing in on this southern Minnesota, northern Iowa zone, as we did 4 days ago, at least at the day 4 time frame. For tornado risk, the Storm Prediction Center has issued the 15% hatched risk region over that moderate risk, and so we're expecting potentially multiple strong to long track tornadoes across the region. The Storm Prediction Center has also spent time talking about this in detail as well below, talking about how there is a conditional chance for significant long track tornadoes, especially here across the more central portions of Iowa, tailing into northeast Kansas. That is a much more conditional threat with a more robust and consistent signal for thunderstorms and supercells here across the more northern part of the mode. So we are potentially planning to target the southern Minnesota region into northern Iowa for our storm chase today, which was our forecast over the last couple of days, so happy to see that it has not changed too much, but maybe have backed up a little bit further west rather than being so much more of this northeastern Iowa, southeastern Minnesota region to potentially more towards the north central portions of Iowa along I-35 into the far southern Minnesota as well, a little bit further west. So pretty much across the board, looks like our forecast is unchanged. We want to take a look at some soundings here, and I have not been able to look at too many soundings this morning, so I look forward to doing this with you guys. And we are going to take a look at the Topeka sounding, because that is the closest sounding that we're going to be able to get here at Omaha area, as Omaha does not launch weather balloons too much anymore, it seems. So from our thermodynamic profile, it seems like we've got a pretty robust area of instability aloft, pretty much primed and ready. We see steep lapse rates aloft, especially in this mid layer. We're seeing very steep lapse rates and a stout EML at probably about 2.5 kilometers above the ground, probably back more towards 2 kilometers, but a really nice moist layer, 69/64 here at Topeka, with a over 1 kilometer depth of moisture. So we do not have any moisture issues whatsoever, as this is just south of the initial part of our target area. So there should not be any issue of this getting to the region. Looking here at the hodograph, and we see what we love to see in the mornings before a severe weather event. We see a sounding that it has a very large looping low level hodograph, indicative of strong warm air advection moving air northward. Not too much of a shock there, but this looks like a pretty loaded sounding here from Topeka, Kansas, indicating that we're probably in for a pretty big day here. We got really strong turning in the low levels here, and plenty of really great values across the board here. Almost over 300 0-1 SRH. A little lower on the storm relative wind at the moment, but that's because the hodograph is more of the warm air advection regime, not so much the open warm sector just yet, but that should get much better with time. And looks like we're dealing with a mixed layer of at least 1500 joules per cape with a most unstable of over 3000 already. So we're pretty much rocking with gasoline here, just waiting for that capping inversion to erode as the forcing arrives here. Speaking about that forcing, we want to take a look now at the portion of the country, or this wide portion of the country, and see kind of where our storm system's at currently. At this time, at 8:45 a.m. of recording this video, looks like our 300 millibar jet and low is centered out over the central Rocky Mountains here, with a nice belt of 90 knot flow beginning to eject off into the plains and starting to really get involved here. Looks like we've got our jet ejecting out into the plains here, and it looks like we're getting a lot of divergence aloft, and you can see that's what supported that MCS through the morning, and has really decayed out here over portions of southern Minnesota and northern Iowa, and has trailed off into the Twin Cities area. So that's an interesting change. I expected more of the MCS to plow through the northern part of the risk area and leave an outflow boundary, but it seems like that's trailing off to the north. We may want to look at some satellite data to see if that's leaving any outflow boundaries or anything to target a little further to the north. But really great jet streak coming in here, and so I'm really excited to see this guy move into the region. Moving down to 500 millibars here, we see our nice 70 knot jet streak is really ramping through the area. Currently now over the Kansas, Nebraska region and moving off into the plains here. And notice how this is going to be pretty much directly over us here in Lincoln and into the northern portions of the risk area, overspreading the entirety of the warm sector there. We're pretty excited about this jet streak, as well as its fast translate speed may help us to have a potentially more impactful severe weather day to day. Low level jet this morning has been absolutely pumping. When we woke up this morning, just getting ready to leave the hotel this morning, cloud cover this morning was moving by so quickly, and yeah, we see a 50 knot low level jet here across portions of the Midwest and Central Plains here. Just crazy moisture transport going northward. A really great sign to see on a big chase day is seeing that low-level jet moving, even visually to the naked eye, when you look up and see the low-level cloud deck really moving out of the way. Already, like we talked about, there's plenty of cape out there. Already 2000 surface-based cape pretty much in the warm sector, really denoted nicely here with surface-based cape, and we see that area really pumping northward and sliding off to the east. Looking at now the surface conditions, we see a beautiful warm sector tucking into a 996 millibar surface low that is already out into northeastern South Dakota, and we see that dew points of reaching into the mid 60s already at this ridge axis as this begins to slide east underneath this low. So I'm feeling really confident that the place that we need to be is going to be this southern Minnesota, northern Iowa zone, right at the apex of this axis of moisture, or just west of the axis of this moisture. I feel like that's going to be the best place that we're going to chase today to see the best overlap of conditions, and just looking at the effective bulk shear across the zone, what helps us really determine for supercells. And we're seeing 60 knots of bulk shear pretty much across the entirety of the plains, so there will not be an issue of generating supercells today due to strong deep layer shear. So that's a really good look across the board. We want to look at our shear vectors. We want to see, are we going to start seeing more parallel flow to our initiating boundary, or are we going to see more perpendicular? Here, what we see out across the eastern Nebraska plains here as it starts to move in, we're seeing pretty much predominantly southwest oriented flow across the board. And actually, let me go to 700 millibars. Let's use this instead. So we're seeing at 700 millibars, we're seeing a nice EML advect through the region starting to go off to the east, and we see temperatures are cooling off rapidly with western extent here, with temperatures falling from 10 degrees Celsius to 4 degrees Celsius or cooler, telling us that lift is on the way and our elevated mix layers should start to erode throughout the late morning and into the afternoon today. Getting pretty excited about this possible chase here. Looks like the flow is going to be fairly similar to the initiating boundary here, and even up north into southern Minnesota, again, the southwesterly flow. And if we pull up in temperature and dew point here, we see that the initiating boundary is fairly, maybe slightly tilted northeast to southwest, but fairly north to south. So that means the boundary is going to be very similar to the 700 millibar flow, which is likely going to lead to potential upscale growth and more of a linear kind of setup, especially further north with extent, which is why we're leaning towards away from chasing central Minnesota. But further south, maybe we get enough overlapping conditions to help us get us more of a tail end Charlie, or where you have a single storm that kind of forms at the bottom of the linear mode and is more of an isolated, semi-isolated storm that takes advantage of the entire warm sector. So we're gonna want to watch this one to see if storm mode wants to agree with us, but that's been the only real question. Does storm mode favor the development of tornadoes and a significant semi-discrete supercells? So we'll see how this plays out, but I'm feeling really confident with this overlapping zone of boundary being laid out, as you can see here, with the contours being really tight here, the northern boundary, and the instability pool coming right into this area. So feeling pretty good about maybe the Spencer, Iowa area, maybe Worthington to Albert Lee to Mason City, Charles City, Iowa. That border zone of Iowa and Minnesota seems to be the place to chase today. A secondary target maybe down here in southwest Iowa, as more recent cam models have started to indicate that maybe we'll start seeing some convective development down there. So we're going to open up the latest HER model here and just look at the 12Z this morning. We see a really nice warm sector develop, and we see the HER model actually initiate a supercell right in our chosen area, which is fantastic, by 22Z or 5 p.m. We have an ongoing supercell, but then we also start seeing thunderstorms develop in southwest Iowa, and those would also have a conditional factor for strong long track tornadoes as well, because we're able to actually sustain storms down there along the southern Iowa border with Missouri. So that is a potential secondary target. If this kind of really starts to flop and get really gross and messy, maybe we can haul south to this area, because I-35 divides the state in half like this. So it'll be a really easy access road for us to bail south as a possible secondary option. But once we've decided on where we're probably going today, that's probably going to be the extent of how far and how long we are able to chase today. Seems across the board like the forecast is going as anticipated and as expected. 6 hours from now, looks like the warm sector should really start growing even more intense with time. So we look forward to chasing today in northern Iowa, and hopefully we have some luck. Forward to bring you all along the chase today, and we'll see kind of what we run into today. Alrighty, welcome back everyone. So current time right now, we look here, it is 1:40. Actually, this is a mountain time, so this is actually 2:40 p.m. here. We are currently sitting in Spencer, Iowa, which is in northwest Iowa, right about up in here. And we have a pretty awesome situation happening at the moment. We are just ahead of a developing storm here. You can actually see it show up here on mesoanalysis with this beautiful ob here of 79/66 dew point. Amazing conditions here just ahead of this storm. We have the dry line, which is arced out here, and a little bit of a lead confluence band, which helped generate a storm out ahead. Now, with us sitting up here in Spencer, this storm is coming straight at us right now. And actually, if I open up some satellite here, we can see that the storm itself is looking really nice, really beginning to blossom here across portions of northwest Iowa. And we'll begin to move towards our direction. We don't feel a need to move too much with Iowa. The beautiful thing is there's beautiful east-west, north-south roads. So we're sitting in such a good spot. The forecast of moving just a little west of our previous location looks to be pretty good. So don't feel like we have too much of a need to go anywhere. Just let this storm develop. Just be patient. We saw this kind of area of confluence entering the region, and then a bit of a zone of convergence as air was being compressed together between these two bands. And you can see that here and that gave us a cue to not go after these northern storms along the dry line cold front, but actually play a little bit further south and wait and be patient, and that seems to be paying off so far. Right now, from here in this part of Iowa here, let's take a look outside. And we have an absolutely beautiful sky. You can actually see the anvils of those storms, not in the tree that's in the way. But our storm is developing beautifully to our southwest, and we don't see a need to move anywhere. It is warm, sunny, the atmosphere is stabilizing, beautiful storms out ahead of us. So can't wait for what comes next, because this is gonna be, I think, a pretty eventful day. I've been getting similar feelings to May 21st, 2024 last year in central Iowa, southwest Iowa, where multiple strong to significant and violent tornadoes occurred. Getting a similar vibe, and I think we're in for a very big day here across portions of northern Iowa and into southern Minnesota. So look forward to bringing you all along with me, and let's see what kind of shenanigans we get ourselves into. Seems the forecast has held true, so pretty optimistic right about now. All right, hello everyone, welcome back, and here we are just north of Spencer, Iowa, and right now we have a really nice supercell that's beginning to go just ahead of the dry line storms behind this guy. Not too visually impressive. We got a nice flat base, a little bit of scud rising into the storm here. Looks pretty decent on radar for the most part. I'm getting blown by some wind here from the inflow of this storm. We're going to see kind of what happens. It seems further south as well, we're starting to see additional updrafts continue to fire down the line. And I'm all about trying to find some discrete storms today rather than trying to chase this linear mode as we go further north. So we're going to keep playing Bilko all the way down, trying to catch every storm intensify, and hopefully some strong inflow here. But yeah, try to play down the line, see if we can catch a storm as they're reaching peak maturity, see if it drops a tornado, keep playing down the line. We'll see if we can follow along the storms to the east, but they are moving 45, almost 50 miles an hour to the north-northeast. If they are right movers, or almost 55 miles an hour to the northeast as a mean wind mover. So gonna be a little tough to keep up with, but I think we can do it. Let's see what this storm gives us here in a little bit.
Join our channel membership and unlock instant access to full-length storm chasing presentations. Click the subscribe button below and then select join, or just click the join button on our profile page.
Alrighty, let's do this. How's my face? Welcome back, everyone. So we are still in Spencer, and these storms have really underperformed. A lot of the updrafts have remained really skinny, small, and they're really fighting the EML aloft, so a lot of dry air aloft, which is not very conducive to small updrafts. And on top of that, there's really strong shear, which is encouraging the storms to really struggle and get merged in with the line of storms coming in from behind. So what our plan going forward is, we are currently in Spencer. The storms kind of look really junky. We're gonna probably keep our options open here. We're seeing more discrete storms forming further south, and the environment looks significantly better with time as we get towards I-35. So I think our plan to be is going to just get super east, let these storms mature with time since they are tending to struggle early. No reason to waste time on early cells. Let's give them the breathing room, let them mature and develop, and then hopefully have a game plan and keep ourselves still in play by playing more eastward towards I-35, maybe Mason City area further north. But we're gonna go town by town to Emmetsburg, then Algona, and maybe from there we'll kind of see what happens. So see you guys at the next update. Hello everyone, welcome back. So time is currently 5:14 p.m. Central Time, and we are near northeast of Emmetsburg, Iowa. We followed the storms to the northeast, but they've been extremely unremarkable. Very high based, very flat, lots of outflow dominance, and linear. So we've started to get a little worried that things were turning gross and we weren't liking it. But we took a quick look at mesoanalysis and saw that the photographs were extremely straight lined. And with the dry line surging out some storms, they've just become all insta-linear and not extremely attractive to chase. So, nice lightning bolt there. We are going to now head back southwest because we see a really nice storm here. But you can see that there's like a tail end Charlie-esque storm. We plan on trying to head down to that storm that's heading towards Emmetsburg. Seems like it's the best storm in the group, and we hope that we can maybe catch some decent structure and maybe continue the tornado threat later, because the low-level wind shear right now is pretty atrocious. So we're gonna see how things go forward. We're gonna bomb southwest here about 25 minutes, and hopefully we have a different outcome than what's ahead of us right now. So we'll see what we run into, but our plan is to get to these storms down to the southwest there. You can see a little blurry, but we can see our dot there in the top right and the bottom left storm there. We'll see how things go, and we'll update you when we get to the storm. Hello everyone, welcome back. So we've gone a little bit southwest. We didn't go quite to Emerson because we figured the storm's coming at us and we wanted to set up a time lapse and enjoy the storm coming in. We've got a really great view here. Actually, we've got a windmill farm here to the south, southwest, and southeast. So we are excited to sit here and watch this storm rotate in. Looks like this tail end Charlie is starting to get quite structured, riding along the outflow boundary of these storms to the north of it. We'll see what happens with this storm, see if we can get a decent view. Feeling optimistic about this storm and starting to see some scud down here on the lower parts of the updraft in that clear area. So I don't know, we'll see what happens with this storm in the future. Let's see what happens. Welcome back, and now we have a tornado-warned storm. Now, right now, visually, this storm is not quite ready to produce a tornado, but in the last 10-15 minutes as this storm has gotten closer, it has become much more disc-shaped. You're starting to see the nice spiraling inflow bands. You're even seeing a really nice curvature of the base itself. So this is starting to look really dang good as the storm is now moving northeast of Emmetsburg, Iowa. And we'll keep following this one to see what happens with this storm. But for now, we've got a supercell, and it looks like it's on its way to getting stronger and maybe producing a tornado. We'll see what happens. Just wanted to give you a quick update with the radar, and this is our storm here. You can see our location here, and you can see that there is a bit of a couplet. Green's going towards the radar, and red's going away, and you can see this little circulation here. Now, this radar is very aloft in the storm, but this is showing us that the storm is in fact rotating, and there's a good chance of seeing a tornado. Time is 5:46 p.m. Central Time. Let's see what this bad boy can do. It's time to move. All right, here we are. Time is 6:38 p.m. We followed along with the tornado-warned supercell, and it got really good and really interesting very fast. But as you can see in all of our perspective, we have entirely gone flat and outflow dominant yet once again. It seems we cannot escape the issue of parallel storm motions to initiating boundaries, and that is inducing a lot of cold outflow to surge out, and these storms can never ingest stronger low-level wind shear, which is causing them to get really flat and continue to be outflow dominant production type storms. And so we're left with a fairly unimpressive, pretty at sunset in the sense of trying to chase tornadoes. This is a rather unimpressive and sad turn of events for a storm chaser. But there are failure modes in chasing, and it seems that today the failure mode is storms have not really been right movers. They've just been mean wind movers and fast moving and outflow production monsters, and it's just led to congealing of storms along the boundary, and it's just turned into kind of pretty grossness. This is the best way to put it. So we're really unsure of what the play is going to be in terms of the chase. It's looking very pessimistic at this point. We'll keep our eye on storms for a little bit. The storm system itself and environment is technically at peak or improving. So if some random updraft forms to the south here, maybe we get a better chance. But from this perspective, it is rather unimpressive.
Hello, everyone, and welcome back. Future Hunter here. The current date is May 8th, and you're probably wondering what kind of happened with this jump in time. We were storm chasing on April. That was a spectacular day for storm chasers, although not for the right reasons. This was a pretty spectacular bust, and I don't use that term lightly. This was a pretty spectacular bust considering the forecasted event that we potentially had on tap. And it pretty much flopped across the board. Now, there were still some tornadoes, and likely damage still occurred with those tornadoes. We're going to talk a little bit about kind of the failure modes that kept April 28th from turning into this hyperactive potential tornado outbreak that most of us were expecting, myself included. So let's jump in first off right into storm reports. All right, so here we are looking at the storm reports for April 28th. As you can tell here, as I zoom in here towards the map here, the Storm Prediction Center has a filtered tab report showing 11 tornado reports across the country with looks like one, maybe two overlaid here in northeast Kansas, but pretty much a nice line of potential tornadoes here. But pretty much across the board, there weren't many tornado reports pretty much throughout the whole thing. And if you remember, this had an extremely large, moderate risk for significant long track tornadoes. So we would have particularly expected more tornado activity across this area, as well as in the enhanced risk zone down here across Red River into western Oklahoma region. But we didn't really get that. And so I wanted to spend some time here viewing what kind of went wrong here. This was a pretty spectacular bust of a day, if I do say so myself. There's a lot of things that we can talk about here because tornado outbreaks, they take a lot to really get working. But to get a day that really flops spectacularly when it seems like a lot of things are really going for it. Now, this wasn't a perfect setup, but there were a lot of things going for it, but they didn't really pan out. So let's dive into some past environments and see if we can decipher some of the issues that may have held this environment back. All right, so here we are looking at the classic thing we all love to look at, SRH. This is, in fact, we're looking at effective SRH. And this is the afternoon hour. This is 18Z, so 1 p.m. Central Time here. And we see here that we're having 200, 300, 0 to, I believe in this case, it was 3 kilometers is about the inflow layer. But large amounts of SRH here, right? So as a storm chaser, big SRH. So, we're going to get tornadoes, right? Let's look at our instability at that same time frame at 18Z. And we think, we've got huge instability, 4,000 Cape, big shear, big Cape. That must mean big tornadoes. And no, not at all. There were a lot of issues starting off the morning, and even this Cape gradient explains a little bit of that. So let's first start off here with a satellite view that I wanted to begin with. So I'm going to zoom in just a little bit here. Apologies, this is the best satellite that I can really find off the get-go, but this will tell us the story. So the first issue that we saw going into the morning was as the sun rose, we saw a large area of stratus and kind of some cumulus across the area, especially towards the western edge, as a little bit more sunlight was able to get to the ground. Time frame at this point is 14Z. So we're looking at, if my math is correct, about 9 a.m. Central Time. And I was sitting out here in Lincoln, Nebraska, starting to see some breaks. The cloud deck was ripping on by with the low-level jet at the time. And I was feeling extremely confident, starting to see some eroding here. But this cloud cover would lead to a potential problem later. As we step forward here, 2 clicks, this now takes us to 16Z, or I believe 11 a.m. And we still see that heavy cloud cover ongoing across all of Iowa, Minnesota as well, with only just a thin sliver of the region able to destabilize and erode that cloud cover, and we actually start seeing some cumulus developing along the advancing dry line Pacific front there. We step forward even further, and we start seeing, oh, look, our warm sector is starting to really open up here, but that cloud cover continues to stay there, and that continued to be a problem through the whole factor, and we see the storms develop in a nice linear fashion, and furthermore formed down along the dry line further south as well. As we go into dark here, we notice that cloud cover continued to hang on, and that had repercussions on the surface pattern because we know cloud cover blocks incoming sunlight radiation. That radiation is required to hit the ground, which then will heat the air by heating the ground. If we're not able to do that process, winds will generally stay more backed, but the air temperature tends to stay cooler. If the sunlight comes out, we're going to start seeing winds veer a little bit more at the surface, but our temperatures go up and we warm the atmosphere. And that's the situation we ran into. And I wanted to pull up now surface analysis from that morning. So now we're looking at 12 UTC or 12Z in the morning of April 28th. And what are some key features that we see here right off the bat to annotate this here? What do we see? Some important features. The first obvious thing we should start to point out is that there is a center of low pressure sitting somewhere roughly about in here, right? Big old spiraling air into the center part of this low here. Really nice wind barbs denoting where the low is, so extremely easy to find. I don't need to contour pressure or anything. What we do also see is our Pacific front, cold front, whatever you want to call it in this case. We'll denote it with this orange line here. Seems like we had this boundary more or less draped in this way. Oh, excuse me, that's a little off. A little more like this. as we see those winds out of the south ahead of the boundary, and behind it, cooler and drier with, well, I shouldn't say drier, but lower dew points with westerly winds out of there. So pretty confident that's where the warm front, or the Pacific front would be. Looking for our warm front now is a little bit tougher because we are seeing higher dew points into the 50s and whatnot, but it seems like there's a bit of a divide where you're getting temperatures in the 50s versus 60s here in the morning. And if we draw it like this, actually, it goes a little bit more south at this point, to about this point. We notice that this is a really not a wide warm sector here. This is a pretty small zone here. And as we saw from the satellite picture, this cloud cover that's sitting out over here does not really go away. It really struggles to get out of that zone. So now let's take a step forward. Look, how did the surface pattern change with time? We're now going to go forward to 18Z. And what has changed? Our low here has more or less lifted off here into the Triple Point State area of the Dakotas and Minnesota. Our Pacific front dry line situation seems to have draped off of this way by this point. Drawing this is a lot of fun. Yeah, so then we see the cold front itself arced out this way. And actually, I should probably use a better color. Editors are going to love this. Apologies. I swear I'm intelligent. All right, so we see the cold front is draped out this way with what looks like probably a dry line-esque feature. We're seeing some wind shifts here. I'm still going to denote as this orange line is more of a dry line in this case. But we see that this kind of separates the zone here from 60s dew points and the lower dew points like this by about 18Z, pretty roughly, but that's generally in the area. And then our key feature, our warm front, where has that gone? Has that changed all that much? And look here, we see that the warm front here separating these warmer temperatures has just continued to remain very pinched off. I'm just drawing the line here between the 70 temperatures and higher dew points. But we see it's more or less draped out this way. Roughly, a little bit harder to find. Maybe the synoptic warm front's a lot more north, but at least at the surface here, the warm front is pretty well stagnant down here in the south. But again, notice the change from that 12Z to 18Z timeframe. This warm sector has continued to just pinch off and has not allowed for a wide breadth warm sector. Because if you remember when we were doing the forecast discussion, especially the day 4 in advance, it looked like this was going to be an extremely wide warm sector. When in reality, this was extremely pinched off due to heavy cloud cover that really struggled to kind of get pushed out of the area. Now, in some events, that's not too much of a problem. In this case, it was a problem because there was now a separation of cool, moist air mass versus warm and moist destabilized, but it was a shrinking area. Not something that tornadoes and supercells like all that much if they want to remain surface-based. So this was a glaring issue by about lunchtime. Remember, this is 1 p.m., so the chase hasn't even started yet. And this was the decision why I wanted to go more south, because seeing this pinched off warm sector, there would not be enough residence time in this zone for storms to mature enough to be able to develop tornadoes in a chaseable fashion. Also, the direction these storms are going to go was going to go straight into the cities, into the forests, and I'm not about to chase that, so I have no interest in this. So this option was a no-go for me. Pretty no-brainer in that situation. The problem then was, what do we have next? If you look here by 18Z, we're starting to see 70s dew points getting in here. That's great. But the problem is, look at the wind field. We're starting to really see winds here with temperatures warming almost into the low 80s here, right ahead of this dry line, which looks great. And if you remember, we looked at this Cape meter mesoanalysis earlier. It showed almost 4,000 surface-based Cape. That's great. But the problem is that Cape was confined to right here. And the further east you got, you ran into air mass that hasn't had nearly enough time to recover from that cloud cover. So all of our strongest shear remained where a lot of these winds remained a little more backed, a little more east out of the south, rather than these guys over here on the sunnier side of the air mass where it's had more time in the sun. These guys became a lot more veered, becoming more south-southwesterly, or in some cases, even southwesterly, which is not great for enlarging our low-level photographs. That would lead to a lot of straight-line photographs in this case, and would likely lead to more hail producers in this case. Not a lot of strong shear to work with. We're already dealing with a pinched-off warm sector. We're starting to develop reasons why this might not be so great. Now, something else I wanted to look at here, and I wanted to pull up higher level mesoanalysis here. All right, so now we're looking here at 700 millibars. And if you remember from the forecast discussion that I had on the day 4 time frame, something we covered was orientation to the initiating boundary. And a good kind of chaser rule of thumb is you want to look at the 850 and 700 millibar layers, because that is where your initial beginning updrafts are going to relatively be confined to. And we want to look for perpendicular to our boundaries. We do not want to be parallel. Parallel orientation to our boundaries will lead to upscale growth, linear modes. And that's not what we're looking for as storm chasers. We want to find those discrete modes. And if you remember with that forecast discussion, and even in the morning of, I was convinced that there was enough perpendicularness to that boundary that we were going to get something similar to this, that we're going to see something more like this. And that would help foster supercell development and get them off of that boundary. So when more storms form, they're not competing with one another. They're not next to each other, fighting for another. And that increases our chances of developing supercells and tornadoes. But unfortunately, what we got was something more similar to this. And this was an immediate first problem that we could see on radar, that the storm mode, especially to the north, when now this was forecast that the northern mode would potentially be more linear, but unfortunately this remained true until we got to the air mass that was too hostile to produce any storms. So I want to pull up here now. Let's slide over some radar. This is from Radar Scope, really great weather app here. And we're able to look at some archived radar data here. And so time currently is 1 p.m. Now will be displayed in mountain time because I am here in Colorado, but note that central time will be just 1 hour later. So in this case, here at 2 p.m., we were actually sitting here in Spencer at the time, waiting for storm development to our southwest. And we got really excited because we started seeing that all this stuff to the north was junk. From a radar presentation for a storm chaser, this is absolutely garbage. And also, forgive the warning here, when I pulled up the radar, it pulls the most active warning. So this is a not accurate weather warning at the time. But as we see, there was one storm that a few of us, when we were sitting down here in Spencer, over here, the storm looked a little bit more promising. It was clearly discrete from the rest of the mode. But notice, if you remember those 700 millibar winds, our boundary is clearly oriented like this, and it actually bends to being more northeast to southwest. So we're actually getting more discrete mode, technically up north, with the boundary orientation alone. But down here to the south, we were having, if you remember those 700 millibar winds, they were very like this, which is very parallel to our initiating boundary, which is not very good. So that, again, further encouraged me to sit here in Spencer and just wait it out. Well, even though this looks like a really great storm to go after off the get-go, this guy here, just east of Sioux Falls, it really wasn't going to be that good of a storm. Now, unfortunately, I do think this is the actual storm that produced tornadoes of the day, but I do not remember seeing any pictures of any of these tornadoes. So keep that in mind. A lot of these tornadoes were brief and heavily rain-wrapped. So we see this really nice flying eagle presentation, strong ventilation, which makes sense, really strong southwesterly winds aloft, helping to ventilate that updraft. It looks really good, but remember, the orientation of the boundary means these guys are not going to get off this boundary so soon. And we see additional storms firing to the southwest, which are already ramming into the inflow zone of that storm, which immediately said, I'm not going anywhere. I'm going to sit here and I'm going to wait in Spencer. And actually, funny enough, what was really cool is that this area here on satellite looked like it developed a confluence boundary that developed right about roughly in here and continued the same dry line. And this boundary was moving slower than the main boundary to the west. And that led to compression of the air mass right here. Because if something is going faster and runs into something slower, it creates convergence. And this was enough convergence to overcome the inhibition that was eroding as you go northward, because that's how we're getting storms, right? They are essentially unzipping down the line as things are becoming more unstable and less capped. So we were really excited to stay down here in this zone. And since we're sitting here in Spencer, we thought, I don't want to chase any of this. We're going to wait and play along here, and we'll kind of see what happens. And we start watching cumulus start to develop along that boundary. We start getting really excited that we're going to start maybe seeing storms and actually start seeing first blips here, pretty much to our due west here, that we're starting to see storms develop. And that got us excited. So now we're going to jump forward to when this storm actually initiated as I load more radar. All right, so now we're about 30 minutes later. It's now 2:30 p.m. Central Time, and we see our storm here really start to develop in that zone of compressing air. And as you notice, it is well away from this linear mess of storms. And so we had no interest in that. So sitting here in Spencer, we got really excited seeing these guys. But as these storms started to really develop, we got excited that maybe, hey, maybe these will be the storms to chase. But notice as I've now clicked towards 2 p.m. now, or excuse me, 3 p.m. Central Time, the southern storm really fell apart. Our main updraft also of our storm here also isn't looking that great. Also, as a third also, that line is getting closer, and notice the behavior of those storms becoming much more linear. They're blobbing into one another and starting to surge out. At this point, that should give you as a storm chaser an alarm bell that a cold pool is starting to develop. And what is a cold pool? And it's air that has descended out of the storm in the precip zone, that is cold, dense air. And when that air hits the ground and fans outward, it helps encourage a linear mode. If you develop a linear mode and then have it on go for long enough, it will generate a cold pool by just evaporating precipitation to the ground as that precip falls, and that will encourage it to surge even more forward. So as you can see, even from these severe thunderstorm warnings here, this is very indicative of a linear mode only. Further to the south, we just maintain an even more capped environment, and it's just not looking great. We want to take a quick look here at our surface map. And as we go forward in time, this is now 2 p.m. Notice that these winds get even more veered in the sunlight. And to the east, notice temperatures in the heavier cloud cover are still remaining in the low 70s. They've not been able to stabilize whatsoever. You've gotten more moisture into the area. Here in Mason City, you're looking at 70 over 66. Ames, Iowa is looking at 73 over 63. And even if you go further west, it gets warmer and warmer. And we're even seeing over here near Atlantic, 79 over 70. That should be great, right? But we continue to veer the surface flow. And that seemed to be the pattern throughout the day, is that this air mass down here, look, even temperatures reaching almost into the 90s here in Omaha, right out along that dry line feature, that it's getting way too warm, and our moisture is not able to help us erode that cap. Even at 700 millibars, we saw that there was a capping issue. And so now I want to pull up some soundings here. And I want to begin first with the 12Z soundings here. Now, unfortunately, Omaha, due to current NWS struggles, we don't have a 12Z sounding out of Omaha. So the Topeka sounding will just have to do, as that is the air mass that gets advected north. And so when I woke up the morning of the 28th, I did display the sounding because I saw this and was like, this is exciting. Sure, the forcing has not arrived, and we have a pretty solid cap here, at least at Topeka, but I assumed further north that we would have more lift, right? That our 300 millibar jet would come in and help erode this cap, that the 700 millibar would cool eventually. At least that was the initial forecast. Spoiler alert, that did not happen. But from this profile, this is an absolutely loaded gun sounding, and any storm chaser would be extremely excited about this, especially if there's reasonable belief this cap is weaker with northward extent, or is able to be eroded with time. So now I want to jump here to the 18Z sounding. So thankfully, Omaha did launch an 18Z special sounding, which they are allowed to do. And what do we see here? And I was sitting here in Spencer, Iowa, right? Northwest Iowa, just ahead of this atmosphere. And I was getting excited because this is a heck of a profile to produce supercells. We're talking almost 4,000 surface-based cape here. Even a mixed layer cape at 2,000 is plenty sufficient. Also, look at the capping inversion, nearly eroded due to the surface heating at this point. So I'm feeling pretty great. We're talking 1 p.m. Storms haven't totally begun yet because the forcing is just coming in. We see the winds now at 500 millibars, now pushing 75 knots. So we're feeling like maybe we're getting there, right? I was feeling really optimistic. While we do have an inverted V and very shallow surface moisture, this would lead to a little bit higher base storms, but these would be much more visible. And that made me a little more excited that with modest deep layer shear here, and actually looking here at the effective shear here, 59 knots is plenty sufficient. That's no longer modest shear. That is extremely sufficient shear to organize updrafts. So this would be a plenty good profile to produce supercells and potentially some tornadoes if favorable things would go down. So I was feeling optimistic that we're going to have mergers, we're going to have storm interactions, we have boundaries, we have instability, we have great lapse rates. Surface lapse rates here in this case were a little struggling, but that's I think more so because of the capping inversion. But aloft, we're looking great overall at the sounding here that yes, this will probably be a first hail mode, as if you think about the photograph, it is very straight lined. till about 7 kilometers, 8 kilometers even. So that would encourage hail production, modest low-level turning, a little over 100 0 to 1 SRH, and a pretty decent storm relative inflow here with the 0 to 1 kilometer layer of 30 knots here, and that would encourage a good-sized storm.
Don't learn storm chasing alone. Go where chasers are already talking. Discord community link in description.
Unfortunately, as we talked about, orientation to your initiating boundary matters, because if we look here at the photograph, we will see, and I'll bust out my marker here, all the storms that initiated to begin with along our boundary. And if I draw it in a little bit from memory, boundary was more or less this way. And storms that were initially following the left mover path along that boundary as they began. As storms began to mature a little bit, they turned to the more mean wind mover. But again, notice the boundary position to where we're going. We could not move off this boundary, especially as the boundary is sagging this way and pushing this way. Our storms just keep getting undercut and shoved forward, which encourages this linear mode. It wasn't until even with a right mover, you were still struggling to get off of your boundary. And especially what kind of happened with our one storm we ended up seeing, there was a larger issue that kind of we ran into. So we'll talk about here in a second. And one more thing to look at here actually is the 19Z sounding out of Minneapolis. We see something that you would think initially, oh, that looks really good, really primed, right? Yes, but your eyes are immediately going to get drawn to this photograph, right? This is a ginormous photograph, strong warm air advection, deep curvature of the low-level wind field. You think this is amazing. And look, there's some instability, maybe some cap here, but this is some instability. We should be good, right? Here is the issue that a inexperienced and honestly even a veteran storm chaser can fall into, is realizing what side of your boundary are you on. We remember back to our surface analysis. This was at 19Z, so let's step it back 1 hour. We see that the warmer temperatures were confined out here to southwest Minnesota, which means all of that low-level curvature and turning was north of our surface warm front, completely stable air that we are not able to effectively use. And if we realize that, hey, that air is stable, what does the rest of the photograph look like? If you look at here at the sounding, you're almost capped to 3 kilometers. So erase the entirety of the photograph beneath 3 kilometers. And this is all that your storm sees, is the 3 and beyond category. It's just going to feature messy storm modes, and you're not going to feel any of this low-level shear, even if a storm survives into that environment. And so this was another glaring issue, was that as the day went on, yes, we started with instability. Was it going to last? Remember, this was the Cape Field. And as we step forward here, this is now 18Z. We see that beautiful blossoming 4,000 Cape here, surface-based Cape here in northwest Iowa. But notice the very capped air mass to the east. We had reductions of Cape almost being halved, and then it was not unstable. It was not destabilizing further to the east. So as you got these storms to develop and they start to become robust in this pretty good environment, they were just too pinched off. As we notice, we don't become destabilized in north central Iowa until 22-23Z. We're already talking, the day was almost over by that point due to storm mode being a massive issue. And so while my initial forecast was we get to the better shear further east and the low-level jet ramps, if we can just keep a discrete storm there, we will get what we're looking for, right? We're going to see those significant long track storms, but we weren't even able to get an isolated storm in a good environment to begin with because of glaring issues in the past. But actually, I look up here because I mentioned that our 700 millibar level, that we would have the cap eroded, right? And that 18Z sounding looked like it did. But here's the problem. You had the cooling pretty much all at the same time. So you just destabilized the entirety of that boundary. So the entire boundary convects. That's an immediate problem. You want some cap to remain to suppress weak convection, and it'll allow the strongest convection to survive. But in this case, you basically just auto-convect everything along the boundary. That's where it's allowed to be. And continuing forward, we just see that continued decreasing of the 700 millibar temperature. So we just encourage this mode of blow up more convection because we can along strong forcing, as we see a really nice troughing here at 700 millibars. And then a important feature here as well, which was something that made me really excited about this storm chase, but it flopped. And if you remember, we talked about jet dynamics and their orientation and like their entrance and exit regions. Because remember, if we have a jet core that looks like this, sorry, my drawing is going to be terrible. And if we cut it into quadrants, That's really terrible, excuse me. We want to chase generally in the left exit or right entrance region of our jet streak. Reason for that is it encourages the correct spin that is needed in the atmosphere to favor rotating storms. This provides lift, and this provides lift, and the opposite is true for these zones where they provide suppression, which will force convection from being as productive in those areas. So in this case, what happened to our jet streak? Because it was forecasted to just shotgun all the way through, and we were going to see storms go crazy because of this crazy translation speed. And while it was fast, it didn't quite go where it was forecasted to. Models wanted to put it into Wisconsin by 21Z. Where did this thing go? So we're going to step forward here to 18Z, and we see that a very long extended jet streak here. But notice here, the core of this jet streak is, and I'm actually going to bring out my marker again. So marking out here the area of strongest flow, it's more or less confined into this zone here. Give or take, it's a little rough, but that generally gets the idea. Now there was a lead shortwave that had a bit of a jet max that came through as well, and that helped kick off the initial convection in the morning. But by this point, by 18Z, it's zooming out of here. That's not really the guy that we're looking for. Now, if we do our jet dynamics and look for our quadrants here, we'll look for something roughly like this and this. We see that our left exit is still maintained out over here, over Colorado and Nebraska for the most part. Even if you extend the jet further north to connect with this, you're still looking at your left exit region is nowhere near where we need it to be. Now, the other option, what if about the right entrance? It is still locked out over here in portions of New Mexico and southern Colorado. So we're now dealing with the right exit region of the jet streak, and that is going to favor suppression. The environment is going to be hostile for the development of new updrafts that are weaker, that are not being heavily overforced and allowed to survive. This would be a theme that updrafts south of the zipping line would really struggle to survive. And if we think back to the radar, where we're talking at 3 p.m., those storms looked really disheveled on radar. How did this jet streak really transpire? Where did it go? If we step forward now to 21Z, and we see that we are pretty much locked in to this either awkward transfer zone between jet streaks in Minnesota, or we are permanently confined to the right exit region of our jet streak. And we see that jet streak pretty much in here. And we are just being permanently locked in this zone of the jet streak. And even following it, if you wanted to even tail it up into the previous jet streak, right? That entrance region was really small, and there was tons of divergence here denoted by the pink magenta lines. We were just left in a zone of either no real synoptic suppression or lift, or just suppression by itself. And this meant all of the updrafts to the south, they were going to do this. They were going to initiate on a rough boundary. They were going to be isolated initially in an environment with a strong EML. That strong EML is hostile to initial updrafts. And then combine strong shear, that makes it even more hostile for those storms to survive. They have to cluster together, merge to build a wide enough updraft to escape entrainment. Thus would kill the updrafts. And that's the case. And if we actually pull up the radar here again to play through, it didn't look good. I was starting to feel a little worried when this storm, we got a visual of it, and it was not looking that great northwest of Spencer. And also the line was starting to really encroach on our storm as well. So we thought, all right, that's a no-go. Maybe the storms further south are going to stay more isolated because, again, there's still suppression, there's capping. Maybe we're going to be able to hold on to an isolated storm down there. So we got lunch really quickly and waited on these storms. But again, we see that as that 700 millibar temperature cooled, we just kept seeing little updrafts blow up along the boundary and hog that space to allow more isolated storm development, So now it is 4:41 p.m. and we were playing in this guy, trying to get northeast to catch up with this storm because it had a really nice base, and we thought maybe that's going to be the guy to go for. But turns out that this guy wanted to fly up in its inflow region and rain us completely out. So we were getting pretty unexcited about it and made the decision over by Bancroft to stop the chase and wait to see if more storms develop to the southwest. Because as you can see, This is just a big old linear mess all the way up into Minneapolis, where your warm sector is basically pinched off to nothingness at this point. We're in dire straits at this point as a chase perspective. We're starting to think, how am I salvaging this chase? Because it's going to crap. Sometimes storm chases just do that. But we continue to hold faith that maybe we'll get a storm. And as you can obviously see from the red box that's sitting there, we do actually end up getting a tornado-warned storm. We see a tail-end Charlie form here. Now, admittedly, I have never actually seen a tail-end Charlie produce a tornado, but when you're out storm chasing and everything looks like either a linear nightmare or that, I'm going to go after the tail-end Charlie because maybe there's some structure. And we watch this guy develop and rapidly become rotating and start looking like it's going to produce a tornado. It got really good looking, had a really nice RFD cut coming in, had a really nice lowered wall cloud, and we thought maybe, but the issue was the final nail in the coffin for this event, if there wasn't already other issues, was these storms here left an outflow boundary that surged out like this. And that meant this storm that we were chasing the entire time, I never felt temperatures warmer than I think 72, 73 degrees and a northeast wind here feeding into this guy, or even worse at times. I think that was probably at the best. Most of the time, we at most had pretty much a due westerly that switched to this more northeasterly wind, but it took a long time to do it. And it was just too stable, too cool. Our storm base was already elevated really highly. So while it was a really cool fake out, it was not enough to really get it done, unfortunately. And so we were left pretty much with a day that decided to flop pretty spectacularly, but it's one of those things where if you chase long enough and you stare at these as crazily amount as I have, you'll realize those failure modes really played out. And these failure modes did in fact keep all of northern Iowa and southern Minnesota out of a pretty massive tornado outbreak given the parameter space that was available, because storm behavior and orientation to boundaries matters. You can have cape values through the roof, shear through the roof, but until you organize and decide on a storm mode, things are going to get junky. And that's unfortunately the case here. But eventually this storm did just continue off to the north and east. I'll actually step forward an hour here because we ended up calling the chase pretty much after this point. Once that storm dropped its tornado warning, we were pretty unremarked by how everything had been. So we see the storm go off to the northeast, and then joined in with the line and just came really sloppy. It just was never given the chance to breathe better inflow, even though the environment ahead of that boundary that was draped out here, that outflow boundary, it just wasn't looking that good. And your eye may have been caught to this guy. This was actually a storm that was breathing in tons of outflow from these storms, but it had a lot of strong shear. And so it actually turned into this cute little supercell that Alex Riesel got some time with, had some really nice stacked pancakes briefly before the storm ran out of instability because these guys pretty much hogged it all. But we threw a pity party and then decided the day is over. I don't know, we're going to look for food. An important rule in chasing, especially if you're a photographer, is just because the day didn't go in your way doesn't mean the day is over. And through some friends, I want to shout out Marcus Reynolds. He encouraged us to come out west and look at the backside of the storm. And that gave us a remarkable display of the back sheared side of the updrafts. Beautiful Mamatis from crisp updrafts, very calloused updraft sides. And it was just a really pretty scene to spend some time back there with some friends, and led to a pretty fun day. And you see there were more additional storms back here, but that pretty much diminished after this point. And I never really felt like I wanted to do a recap video that night because we ended up racing at a storm that formed down here as the low-level jet increased, but that storm also quickly went outflow dominant and produced nothing, even though it became tornado warned. So it really was just overall a flop of a day from my perspective and what I saw that day, which was a little disappointing, especially because I love Iowa and it's a beautiful place, but I don't know, those moderate risk days that cover Minnesota as well, they don't turn out so good. But that's all joking aside. Mother Nature doesn't listen to us and our fake lines that we draw. She's the one that decides what kind of goes down, and we're the ones that are trying to listen and understand. But this, overall, my final wrap-up thoughts of this day, it underperformed, and I was feeling pretty defeated after this storm chase because we made the decision also to chase here in northwest Kansas the day before and not go to my target location in Ogallala. And that cost me seeing multiple large tornadoes here just north of town, which would have been a lot of fun to go chase. And for those that got to go see it, it was amazing. But sometimes, even if you're experienced, you can bust, and it happens. And so to go 2 days in a row of pretty hardcore busts of you made the wrong decision, so you missed out, and then you made the right decisions, but the weather didn't produce. That is storm chasing in a nutshell. That being said, we still had a blast of a time because it's important in storm chasing to set what makes it valuable to you. If your goal is to only 0 meter a tornado, so to speak, and that's the only thing you derive your happiness from, you are going to be a very sad, angry individual for almost all of your storm chases. There is so much more to storm chasing. We enjoyed some wonderful food. We ended up running into a local Subway guy who knew all of us chasers on social media and wanted to take a picture with all of us. And that was really cool. We got to see parts of the country that I'm familiar with and areas that my chase partner at the time wasn't familiar with. So it was cool to go see new places and spend time with friends. And we did see pretty storms that I even got pretty decent photographs of. And I had a good time chasing, even though I was disappointed in the outcome. And so I guess the closing message here is just you can forecast everything. You can think you understand, but Mother Nature will always throw you curveballs. Sometimes you might not be fast enough to pick it up on the fly, or sometimes it's just not going to work. But for the amount of times that it really doesn't work, it also does. And you will be able to see tornadoes when you're out chasing. I do believe that really good executed storm chases that bust will teach you more about meteorology and storm chasing than succeeding every single time. Because if you succeed too much, you will train yourself to only know what success is. And so when a bust comes along, you will not know how to handle it. So I encourage you to get out and chase, even if it's a bust. And I hope this Chase and Explain has been helpful. And thank you so much for coming along. I look forward to the next one, and hopefully we'll have a little bit more success.
Remember to check out those links in the description below, and then watch another video.